It's a hot day, and you're keen to go get some ice cream. To do that, you have to go to the shop. The shop in question is just around the corner from where you live. Let's say you decide to take this path. When you are at the shop and you've bought your ice cream, take a moment to consider the physics of the situation. I'm going to pose two questions. How far did you walk, and what is your displacement? The first one is easier to answer. How far did you walk to get from home to the shop? In other words, how much distance did you cover? Using a map, an app on your smartphone, or even just intuition, you can come up with a distance in meters. How many meters did you walk? Let's say it was 40 meters up this side of the block, then 30 meters along the other side. Add those distances up and you get 70 meters. That is the total distance you walked to get to the shop. Unfortunately, you'd have to travel a bit further to burn off all the calories from your ice cream. Now the second question. What is your displacement? By now you should know that displacement is a sciencey word that describes the shortest distance between your starting point and your finishing point. Your starting point is home, your finishing point is the shop. Displacement is the shortest distance between them. What's the shortest distance between 2 points again? It's a straight line. So let's take this map and draw a line like this. Do you notice anything special about the map now? We have a right-angled triangle here. Your displacement is represented by the longest side of the triangle. The other two sides are the lengths you actually walked along. Brilliant! Right-angled triangles can be tackled using something called Pythagoras Theorem. Pythagoras himself was a mathematical genius. He lived over 2,000 years ago, but his work is still essential for working out problems like this. His theorem can be summed up by this equation. C squared equals A squared plus B squared. A and B are the two shorter sides of the right-angled triangle. C is its longest side, which happens to be your displacement. So we can use those two known lengths to calculate your unknown displacement. I'm going to run through the working using Education Perfect's very snazzy maths working input. If you need help following my steps, feel free to pause the video and look in our mathematics topics for more info about Pythagoras' theorem. First, let's write down the equation. C squared equals A squared plus B squared. Now I'm going to say the length A is 40 meters, length B is 30 meters. It doesn't really matter which is which, because we are adding their squares. 40 squared is the same as 40 times 40, which comes out as 1,600. If you need it, there's a very nice calculator pop-up which you can use by clicking on this blue square on the right. There you go. Now then, 30 squared comes out as 900. In order to get C, the displacement by itself, we need to take the square root of both sides. Square root undoes the square. So this equation becomes C equals square root, which is this sign here, of 1,600 plus 900. Don't worry, we are almost there. Crunching the numbers gives us a final result of exactly 50 meters. I'll just type that on its own line, and now the whole thing has turned green, which tells us we've got the right answer. Displacement needs a direction too. Have a look at the compass on this map. Can you see how you'd have to move northwest to go from home to the shop along this line? The direction of your displacement is northwest. So your displacement from home is 50 meters northwest. Good show! Why on earth do we need to know about displacement? Walking to the shop may seem like a trivial activity, but there are a huge range of situations where the ideas of displacement and Pythagoras' theorem come in handy. Such different things as launching rockets, building towers, predicting landslides, and crushing your enemies with a catapult all depend on this knowledge, so yes, it's a big deal. And now I think it's time for another ice cream.